Hello friends, today let us verify one property of number of elements in a set. So first let's understand what is the property. Suppose there are two sets given, set A and set B. Then we can do two operations on it, that is A union B, that is we take all the elements from these two sets, and the another property is A intersection B, in which we take all the common elements from these two sets. Now in this case we get four sets, then we have a relation, then we have these four sets. If we take the number of elements from each set, there is a relation amongst the number of elements in all those sets. That is, we have n of A union B, that is the number of elements in A union B. Then we have n of A, that is number of elements in set A, n of B, that is number of elements in set B, and n of A intersection B. So there is a relation amongst all these number of elements in all these four sets. That is, if we add number of elements in set A and set B, and if we subtract the number of elements in A intersection B, that is equal to n of A union B. So this is the property. Now we are going to verify this property by having one example. So let us consider in set A we have elements small letter A, B, C and D, and in set B we have element B, C, D, E and F. So these are the two sets. Now if we find the A union B, then we have to collect all the elements from both of these two sets, that is A, B, C, D. These are the four elements from set A. Then B, C and D, these elements are repeating in set B, so we have already taken these in the union, so we cannot repeat that. Apart from that, we have element E and F. So this is A union B, and we can find A intersection B by having all the common elements only. So in both of these two sets there are three elements in common, B, C, D, and here also B, C, D. So we can write these elements B, C and D in A intersection B. Now we can have n of A, that is number of elements in set A. So in all there are 4 elements, so n of A is 4. N of B, there are 5 elements in this set, therefore n of B is equal to 5. Then we have n of A union B, that is equal to, there are 6 elements in all, so n of A union B is equal to 6, and n of A intersection B, that is equal to B, C, D, only 3 elements are there, so that is equal to 3. Now we have the relation in which we have to add number of elements in set A and number of elements in set B. So on the right hand side we have n of A plus n of B, and from that we have to subtract number of elements in A intersection B, that is n of A intersection B. So n of A is 4 plus n of B is 5 minus, we have to subtract the number of elements in A intersection B, that is 3. So here 4 plus 5, that's 9 minus 3, that is equal to 6, which is the number of elements in A union B. So that is equal to n of A union B. So this is to verify that n of A union B is 6 and n of A plus n of B minus n of A intersection B is also 6. That means n of A union B must be equal to n of A plus n of B minus n of A intersection B. So this is the relation which we have verified here by having one example. I hope you understand this concept. Thanks for watching.